All right, in this video, we're going to discuss interpreting what we're doing when we're integrating. So suppose R of t is the rate at which water flows into a reservoir in gallons per hour. What does this integral represent? Well, T1 is the start time. T2 is the ending time. And the area, so if this is R of t, say this is what R of t looks like. And here's T1 and here's T2. Well, this total area, and this is water flowing in. So this is gallons per hour and this is hours. This area here, when we figure out this area, we're going to multiply gallons per hour times hours. So let's think about that. That's going to leave us with just gallons. This tells me that this integral here represents the number of gallons that have flown into the reservoir between T1 hours and T2 hours. So between T1 hours and T2 hours. Whew, okay, that's a little crowded in there, but let's keep going. Suppose m of t is the constant velocity traveled by a car in miles per hour. What does this integral represent? So again, we can draw a sketch, and this is really similar to examples we've already done about velocity, and I said it's constant. So here's m of t, and here's 2, and here's 6. And again, the car's traveling in miles per hour here, and this is time in hours. So let's look at this area here. The integral represents this area, and when we compute this area, let me do that here. You'll end up multiplying miles per hour times hours, and these cancel out, and you'll end up with just miles. So this represents the distance traveled in miles between 2 and 6 hours.